So lastly, we're going to look at way back to section 1.6. That's solving other types of equations. I skipped this in the prerequisite part of the course and kind of jumped right into the 2.1, 2.2 sections, the ones involving functions and domains and ranges, all those things, because this one's technically a review of previous content, we would hope, but it might not be, and I want to make sure that you're exposed to it if you are moving on and taking pre-calc or anything like that. So here we have polynomial equations. We're going to solve these by factoring. These should be pretty old hat by now. We should see this and understand that what I need to do is I need to move this over to the other side. So I'm going to get 4x to the fourth minus 12x squared equals 0. And I can factor out a greatest common factor. So in this case, that's going to be a 4x to the second. And I'm left with x to the second minus 3 equals 0. Now that means that 4x to the second equals 0, which means x to the second equals 0, which means x equals 0 is one of my results. That would have a multiplicity of 2. Okay, so it's a touch point instead of a cross point. That's going back to our last test, or test 3 content. Then we have here x squared minus 3 equals 0, so x squared equals positive 3, so x equals plus or minus the square root of 3. So we would have, we have 3 zeros, but one has multiplicity of 2, which should match our degree of our polynomial. So this factoring, we have to always make sure if we're going to solve this equation, anytime we have a polynomial, we need to make sure that it's set equal to 0. So we have to move things over if they're not already done so. On the next one, we have this polynomial, 2x to the third plus 3x to the second equals 8x plus 12. We're going to move these over to these two over to the other side. And we end up with 2x to the third plus 3x squared minus 8x minus 12 equals 0. Now we're going to group some of these terms together because I want to group these two terms together because I can pull out 2x and I'll end up with a x squared minus 4. And if I do the same thing with these two terms, I'll get those two similar terms that I can factor out. We're going to do this by factoring by grouping. That's essentially what I'm saying. So we have 2x to the third minus 8x plus 3x to the second minus 12 equals 0. On this first one, we're going to factor out the 2x. On the second one, we're going to factor out the 3. And what remains here will be x squared minus 4. And here we're going to end up with x squared minus 4 equals 0. So now I can factor by grouping because both of these terms are to pull out the x squared minus 4 because both of these terms have an x squared minus 4. So I get x squared minus 4 times 2x plus 3 equals 0. Now I'm going to take each of these terms and set them equal to 0. I'm going to do that in blue on to the side. So x squared minus 4 equals 0. So x squared equals 4. We're going to take the square root of both sides, which gives us x equals the plus or minus answer, remember, and the square root of 4 is 2. So this is two of our solutions. Then we have 2x plus 3 equals 0. And so we end up getting x is equal to 3 halves. Just leave that as a simplified fraction. So nice check to see our degree of this polynomial is 3. I have 3 zeros. Plus 2 or positive 2, negative 2, and 3 halves. Next, we're going to look at solving radical equations. And one thing I want to note here is that a radical, when it's just a normal regular old radical, is the same thing as saying x to the 1/2. And remember, when we're solving for a variable, we want to make sure that our exponent on the variable is a 1. So how do I get rid of a 1/2? Well, I would have to multiply it by 2, okay? Because 2 times 1/2 is equal to 1. So that's why the inverse, I mean, that's not why the inverse of square rooting is squaring, but it should make sense that this is what's happening. Now, the reason why I wanted to show you this is because that's going to show up when we have exponents that are rational numbers or fractions. And so this concept of like multiplying by the reciprocal is how you get rid of a fractional exponent will show up again. Okay, now in these it's actually not as hard as that though, because the opposite of square rooting of something is squaring something. So if I'm going to solve each of these equations, the first one is square root of x is equal to 9. So to solve that for x, we're just going to square both sides. That cancels the square rooting, so we get that x is equal to 9 squared, which is 81. On this next problem, we're actually going to start by moving this 3 over to the other side. So we get the square root of x plus 3 equals x minus 3. Now, we want to undo the square rooting on the left-hand side, so we're going to square both sides. So this square root will cancel with the squaring. So on the left-hand side, we're going to be left with an x plus 3. But on the other side, we actually have to square this binomial. So that's going to give us x squared minus 6x plus 9. Okay, so please make sure you don't make that mistake where you say it's x squared plus 9. Don't do that. That's wrong. You have to, essentially, you're foiling it out and doing x minus 3 times x minus 3. Okay, so make sure you do this correctly. Now we have a quadratic, so I'm going to move these over to the right-hand side, so I'm left with a 0 on the left, and I have x squared minus 7x plus 6. This factors nicely, so I end up getting x minus 6, x minus 1. And so therefore, I end up with two solutions. X is equal to 6 and x is equal to 1. You get that by setting x minus 6 equals 0 and x minus 1 equals 0. So those are two solutions to this equation. Now I can check this. Now here I say always check your answer, and I definitely didn't do that for the first one. But I'm going to check it for the second one. So if I take the square root of 6 plus 3 plus 3, does that equal 6? Okay, well, that's going to be the square root of 9 plus 3. Does that equal 6? Okay, well, square root of 9 is 3. 3 plus 3 equals 6. We are good to go. Let's check the second one. Square root of 1 plus 3 plus 3. Does that equal 1? When we solve this, we get square root of 1 plus 3 plus 3. Does that equal 1? Square root of 4 is equal to 2. 2 plus 3 equals 1. That is false. That is not true. So we throw that solution out. X equals 6 is my only solution. So that's why it's important that we check our answer to make sure that we get one correct solution for this, and check to see if both are possible. Who knows, right? Double check. Always check both of them. I'm going to leave that last one for you to do on your own, because we're going to move on. Here are expressions with rational exponents. Remember, a rational exponent, that's a fraction, indicates a radical. Okay, so we're going to solve each equation. Now, this goes back to what I was saying before. If I want to cancel a 3/2 exponent, okay, I'm going to have to raise this to the reciprocal power. So the reciprocal of 3/2 is equal to 2/3. So I'm going to take this 8 to the 2/3. Those will cancel, leaving me with x equals 8 to the 2/3. You can think of this and rewrite it as the cube root of 8 squared. Or you can think of this as what's the cube root of 8 squared. Either way you can think about it, gets the same result in this case, because the cubic root of 8 squared is 64, and the cubic root of that is 4. And the cubic root of 8 is 2, and 2 squared is 4. So you get the same result. Also, you could just click this into your scientific calculator by doing 8 to the 2/3 power. You just have to use the little caret to show that power. For the next one, we're going to move the 25 over and divide by 5. So we are going to end up with 5x to the 3 halves equals 25. Divide both sides by 5, so I get that x to the 3 halves equals 5. And so to get rid of that 3 halves, we multiply by 2/3, or not multiply, multiply the exponents by 2/3, or raise it to the 2/3 power. I'm like, watch your phrase, Anna, don't say it incorrectly. And we end up that x is equal to 5 to the 2/3 power. Okay, again, you could write that as the cubic root of 5 squared. Now that's how we're going to leave it. That's an exact answer. Okay, if I use my calculator to solve that, I'm going to get a very long decimal answer. If they want you to have a decimal answer, the question will ask you to round. If they don't ask you to round, they want an exact answer. Leave it like this. Okay, this last one, we're going to add 8 to both sides. So we get that x to the 5/4 equals 32. Okay, so to undo the raising to the 5/4, I'm going to raise that to the reciprocal of the 4/5. But I have to do that on both sides. Okay, so then we end up, those cancel, leaving me with x. And the 5th root of 32 is 2. Raised to the 4th power is 16. Okay, again, you can put that in your scientific calculator and double check, but yes, this is 16. So the last two equations we're going to look at is solving things that are in what's called quadratic form, which means that they're not quadratic equations. And if you see here, the degrees are not to the 2nd power, okay? But they have the quality where they look like a quadratic equation. And I wrote the general quadratic form equation on the right-hand side of your screen. The form is a times x to the m plus b times x to the n plus c equals 0. So it looks like a quadratic, and m has to be equal to 2 times n. So both of these examples, 4a and 4b, are written in quadratic form. 4 is equal to 2 times 2. 2/3 is equal to 2 times 1/3. So both of these are written in quadratic form. Now, the first one is nice. We can actually just factor it. Okay, now the factoring for this is very similar to how we would factor a quadratic. We're looking for two numbers that multiply to get 6 and add to get -5. Okay, but my first term in the binomials isn't just an x, it's going to be an x squared. Okay, that's because the leading coefficient is a 1, so we don't have to worry about factoring by grouping or anything like that. But we end up getting what two numbers multiply to get +6 and add to get -5. That's going to be -2 and -3. Okay, so now I have two terms that I can set equal to 0. X squared minus 2 equals 0, and x squared minus 3 equals 0. So we end up getting that x squared equals 2, and x squared equals 3. And when I take the square root of both sides, we're going to end up with x equals plus or minus the square root of 2, and x equals plus or minus the square root of 3, which gives us 4 solutions, which makes sense because that is a 4th degree polynomial. Now, this one on the bottom looks a little scary, but we can use our AC method, our factoring by grouping, to solve this. Just note that when we have our terms, we're going to have fractional exponents, and that's okay. So first thing I'm going to do is multiply 3 times -4. I get -12, and I'm trying to add those together to get -11. So that's going to be positive 1 and -12. We rewrite the middle term negative 11 x to the 1/3 as negative 12 x to the 1/3 plus x to the 1/3. And you don't have to write the 1 in front of it like I did. I just like to have that there just as a reminder that it is there. Sometimes I write it as that ghost 1. Now we're going to factor by grouping. So I'm going to pull out a greatest common factor within these two terms. That's going to be a 3x to the 1/3, which leaves me with an x to the 1/3 minus 12. Well, just kidding. That's going to be minus 4. And then on this other one, I can't factor out anything, but I'm going to rewrite it as a factored out 1. And that's going to leave me with an x to the 1/3 minus 4. Again, I'm going to keep that in there so I can see that when I pull that out, what remains. Okay, so these both share an x to the 1/3 minus 4 term, so I can factor that out. That leaves me with x to the 1/3 minus 4. I'm going to draw a little line to separate these. Times 3x to the 1/3 plus 1 equals 0. Okay, so all of these are equal to 0. Now I can solve each of these. So I'm going to take this, x to the 1/3 minus 4 equals 0. So I get x to the 1/3 equals 4. So to undo the 1/3, I'm going to raise both sides to the third power. This goes back to previous examples we saw. 4 to the third power is 64. This one over here, I'm going to take 3x to the 1/3 plus 1 equals 0. So 3x to the 1/3 equals negative 1. Divide both sides by 3. So I get x to the 1/3 equals negative 1/3. Raise that to the third power. And I get that x is equal to negative, what is that? Negative 1/27. So I get two solutions for that. Again, you're going to want to check your work, substitute those in, make sure you get a 0 for both of those. But these are solving other equations, other types of equations. So hopefully you look through this and brush up on these types of examples. Thank you.